Hello Harlem Lacrosse Scholars. In this video we're going to be taking a look in the Algebra 1 section at assignment J2, the one that's called Write and Solve Equations that Represent Diagrams. And as the assignment title suggests here, your job really is going to be to write an equation based on diagrams, or what I'm going to call number lines, that they give to you. First thing I'm going to do is take a read of the question. The question says, write an equation that says the length of the green line is equal to the length of the black line. Combine like terms. So here I see a situation, and I'm going to go ahead and use my highlighter tool. In the green box, that's one of the diagrams, or one number line, and that's 23. And then I'm going to go ahead and use a different color, we'll call it purple, for the other box that has an S block to it and a 15 block to it. And our job is to write an equation that says these two parts are equal to each other. And an equation is always really just going to have an equal sign, and it's going to say two parts are equal to each other. It says the left expression is equal to the right expression. That's all an equation really says. And here, the left expression, or one of the two parts that we're saying is equivalent, is 23. So I'm going to go ahead and plug that 23 into the left side of my equation. And the right side of this equation, or the right expression, is going to need to have the purple block, which shows me a block of S and a block of 15. I don't know what S stands for yet. It could be any quantity. To me it looks like it's smaller than 15, but I don't know what S represents yet. So because S and 15 are not like terms, I'm going to go ahead and put a 1S. There's really one copy of S here. And as I noticed, their directions said combine like terms. The only like terms are the 23 and the 15. But I'm not allowed to combine those. An important thing in math to understand with equations is I'm only allowed to combine things. Give me 1 second. I'm going to draw a line right through this equal sign if they're on the same expression or the same side of an equation. So the 1s and the plus 15, they're not like terms. They can't be added together. And the 15 and 23 are like terms but on different sides of the equation, so we're not allowed to add them. So ultimately that tells me my equation is just 23 is equal to 1s plus 15. And if you want, in math, we tend to simplify. Anytime there's only one copy of a variable, we just write s instead of 1s. I'm not going to keep reading the question because for each of these IXL assignments in J2, the question remains the same. They ask you to write an equation that says the two bars are equal to each other. Here for my equation, I see the left side of my equation needs to have 40. The green bar is simple, it's just 40. And then the right side of the equation has to have everything that's in the black diagram, or this black number line. And there are three pieces to it. The first piece is 2k, the second piece is another 2k, and the last one, there's no number written here, so as we talked about earlier, I'm going to write that as a 1k. It really means there's one copy of k in that last piece of that diagram. Now an important thing, we've talked about this already, you see they're going to ask you every time to combine like terms. And in this equation, when I go ahead and draw a line, or what I call the river in the future, through this equation, I see the 2k, and the 1k, all three of these terms are on the same side of the equation. So in that case, I'm actually allowed to combine all three of these. 2 plus 2 plus 1 would give me 5. So in this case, when I combine the right expression, the three terms with k in it, they sum up to 5k. So that tells me that this equation is going to be 40 is equal to 5k. I'm going to fire through a few of these very quickly just to show you answers. I think that they ask you to solve a couple of these equations, so I do want to show you that. So I'm going to go ahead and plug in some answers pretty quickly here. Hopefully you can see where they're coming from. This one, 35 plus 6 equals 6s plus 1s, but I need to combine those, and it would give me 7s. Here, 24 equals f plus 9, or 1f plus 9, and the combined like terms doesn't come into play because f and 9 can't be combined. They're not like terms. Power through a few more, and I'm just going to see if they ask you to ever solve these equations like the title of the assignment suggests. I'm going to add all of these h's together, 2h, 4h, and 1h. 6 plus 1 more would be 7 h's, plus 12. And really important thing, I cannot add the 7h and the positive 12 because the 12 doesn't have an h variable attached to it. And it looks like potentially, even though their assignment says to write and solve equations that represent diagrams, I'm up to 55 here and they haven't asked me to solve one yet. Alright, they do get a little more challenging. Here, they say write an equation, and this is why maybe my advice earlier wasn't great. I should always read the question to start. This time they say write an equation that says the length of the green line is equal to the length of the black line minus the length of the blue line. And then they ask you to combine like terms. So I'm going to go ahead and highlight this and read that one more time because it's gotten trickier now, and that'll happen to you on IXL as the scores go up. It says write an equation that says the length of the green line is equal to the length of the black line minus the length of the blue line. Combine like terms. So breaking that down, let me take off the magnifying glass. Alright. For an equation here, that's weird. Text tool's not working. Thanks for being patient with me. Alright. So in this case, we're going to start writing an equation, and it needs to say the green line is equal to the black line minus the blue line. And you can kind of see in their diagram here, I'd normally think of this as green plus blue is equal to black, but you could also write an equation that's formed to say, well, you could find green if you take the length of the black one and subtract blue, all you'd have left over is the green one. So here, in this case, here's my template that I need to be using for the equation. Green is going to have to be equal to the black line minus the blue line. I got that from the language of the question. And now I'm going to take the green line, which is 3, and substitute or plug that 3 in for the green value. I'm going to put some parentheses in here too, which might be good for more complicated problems in the future. Here the black line only consists of a 4, so I don't need to use the parentheses. I can replace the black value by 4. And the blue is only represented by one copy of n. That's the entirety of the blue, so I'm going to replace the entire blue term with a negative n. Now I've gotten this new equation. 3 is equal to 4 minus n. They do tell me here I need to combine like terms. That's part of the question. But here, again, a reminder, and we'll draw the river one last time. If I have like terms that are not on the same side of the equation, like the 3 and the 4, they can't be combined. And in this case, the 4 and the negative n are gathered on the same side of the equation, but they're not like terms. So here, there's nothing further to simplify. The equation they're looking for is 3 is equal to 4 minus n. This question asks us, it says, write an equation that says the length of the green line is equal to the length of the black line. So again here, pretty straightforward. 18 is equal to all of these pieces added up. That's going to give us 6t when we add up all those t's. Here, again, write an equation that says the length of the green line is equal to the length of the black line. Go ahead and add all these up. I'm going to put tick marks over these. I have 1, 2, 3, 4, 5, 6, 7, 8 different copies of that k. So I'm going to have to say 48 is equal to 8 copies of that k. That's easier than writing out all of those and then combining them. And it does look to me, now that we're up to the 70s, I don't think they're actually going to make you solve any of these equations. One last thing, anytime you're above 70 on IXL, I think that's fine. It's your choice whether they do get more difficult as you go, so it's your choice if you want to keep pressing up towards 85, 95, or even 100, which is the highest score you can get to on an assignment. Thanks for watching to the end of this. Hope it was helpful. Feel free to email me if you have any questions.